Welcome, everyone. My name is Rat, and I'll be the chat moderator for today. Here with me is Simon. He would be answering your technical questions. Do let us know if you have any questions during the session. The session is recorded, so you'll be able to watch it afterwards. And the session has started, so if you have any technical issues, please refresh your browser or open the link in a Chrome incognito window that also should work. Please let us know if you have any issues. Our presenter, our amazing El Toro, Andres Perez, one of our technical instructors, is here to tell us more about JavaScript Event Loop. Thank you, Andres.
Thanks, Rad, and thanks, Simon, for helping out, monitoring the chats. I cannot multitask, although I told my manager when she hired me that I was an excellent multitasker, so I cannot speak and read and answer chats at the same time. So I thank you so much for helping out with that. We're going to start with the presentation here called Understanding the JavaScript Event Loop. As any regular session in Dreamforce or conference is similar to this, we have to go through this slide, although it really doesn't apply for this particular session, since we're not going to be talking about Salesforce products. We're talking about JavaScript. But nonetheless, please do not make any purchase decisions based on the future of Salesforce. Base your purchase decision based on the currently available features of Salesforce. As Rat mentioned, my name is Andres Perez. I am a global principal technical instructor. I've been around Salesforce for over 10 years. You can reach me at my LinkedIn, El Toro IT. I'm calling right now from Canada. And I have several certifications, including the JavaScript developer one, which is the one that I'm hoping this session will help you prepare for. So the session is divided in several segments. First one is titled, JavaScript is what? Second, it's what would a flowchart look like? And can you show us some code? And then we'll wrap this session with some Q&A. So JavaScript is what? Can JavaScript execute multiple tasks simultaneously? But let's define some terms before we actually answer this particular question. A task is the smallest sequence of instructions executed independently. And task runs inside threads. So a single-threaded application where your tasks execute in sequence and new tasks can only start after the previous one completes, taking turns, of course, which make it appear to be simultaneous. This is actually a technique called concurrent programming. This is very, very easy to code compared to multi-threaded applications where the tasks may execute in parallel. A task can start before a previous one completes. Sometimes a task may need to wait for other tasks to complete. This is harder to code because you do have to worry about synchronization. What about JavaScript? Synchronous, asynchronous, single-threaded, multi-threaded. Actually, I'm going to, in this presentation, compare JavaScript with a pizza restaurant. Yes, you heard right. So is JavaScript single-threaded? Yes, it only performs one single task at a time. It's like ordering a pizza at the counter, where you stand in line at the counter until you can order the pizza. You place your order without being interrupted, and you sit down at the table and wait for the server to bring the pizza to you. What does this have to do with JavaScript anyways? Well, actually, this is very similar to the code that you do write. Being single-threaded makes your code simple to write. You don't need to worry about sharing resources because the browser will execute your code when the browser is ready to do so. And your code will run to completion without being interrupted, unless you want to wait. This makes your code really, really easy to write. But doesn't it make that JavaScript blocks other tasks? Yeah, but let's talk about blocking. What does it really mean? Imagine if ordering a pizza was a single-threaded blocking process. Customer walks up to the counter, places the order at the counter. It waits for the food at the counter. It eats at the counter, pays for the pizza at the counter, and then it leaves the restaurant. At that time, then the next customer can be served. What's wrong with this picture? Well, customers will have to wait forever to eat. The queues would get out of control. That's why tasks should take turns, especially long-running ones. And in the case of the pizza restaurant, you're going to hear something like, please wait at the table, we'll bring the pizza to you. Wait. I thought JavaScript was multi-threaded. Well, it sure feels that way. But the trick is the browser. A restaurant manager worries about things like, for example, keeping the customer's queue organized, processing many pizza orders per night, serving the food efficiently. What does this have to do with JavaScript? The browser manages the queues. The browser runs multiple tasks. This is harder to write because you have to deal with orchestration. But luckily, we're not writing the browser. We're just writing JavaScript, which is a single-threaded, synchronous blocking process. Wait, but that's horrible. Yes, I do agree. But the JavaScript engine is more than just a JavaScript language. So if you think about the browser, inside of it, you'll have the JavaScript language, which has things like the heap. This is where the variables get stored or managed. And you have the stack, which is a LIFO, last in, first out, data structure which keeps track of the sequence in which the functions are being called. You can see that when you are troubleshooting your code, or if you do get an exception, you'll get the stack trace. But the browser, it's a lot more. The browser also has the web APIs, which is what it uses to handle asynchronous programming with things like DOM events, XML HTTP requests, including fetch, timers, including set timeout and set interval, promises, etc. It also, of course, has the event loop, which basically manages the queues. And you have two types of queues. You have a task queue, and you have a microtask queue. Wait, hold on. Do you say tasks and microtasks? Yes, and they are very different. A microtask includes things like promises, including then, catch, resolve, reject. For the most part, your microtasks will be promises, but it also has functions to enqueue in the microtask, or it has the mutation observer, which through microtasks, it manages the state of the DOM. Tasks, which include the regular execution of JavaScript. So for example, if you have an HTML page with this alert, that will be executed as a task. Also, if you run some code from the console, that will be executed as a task. Event callbacks, timers, and set timeouts also work as tasks. The important part here is that microtask takes precedence over tasks, meaning that they will run until all the microtask queue is empty, including new microtasks that were queued during the current event loop cycle, which means that this could block the execution of the code. Okay, what does the event loop do? Well, in one word, orchestration. If you consider the browser, and we're going to take a look at the picture here, and we're currently running a middle of a task, because you see that the stack has some information inside of that. As the task starts getting processed and all the functions get returned and whatnot, few tasks did arrive, but none of them got started because the stack was not empty. Now that the stack is empty, it will take the first task and execute that. So once it gets executed, it may create other tasks. It may also create other microtasks. So then once this task is done, it's going to take a look at the queues, and the microtasks takes precedence. So we'll execute that microtask first. And if any microtasks arrive, all of them will be executed until the queue is empty. Now, there's no microtasks, so we start with the first task. And then we execute the first task, and we continue until there's more microtasks or other tasks, or the queues are empty. So if we wanted to take a look at a flow chart, what would that look like? Well, the event loop is basically a big loop where it repeats over and over and over and over until we kill the browser. One of the first things that it does is to check if there's any tasks. Because if there are not tasks, then it will just loop around and ask again. But if they are, then it's going to execute the oldest task. Notice that only one task is executed, regardless of how many are on the task queue. Once this step is completed, it's going to ask if there is anything on the microtask queue. Is the microtask queue empty? If it is, then we don't worry about it. We just go around the next loop. But if there is something on the microtask queue, then it's going to execute the oldest microtask, and it's going to go around and ask again, is the queue empty? And if any microtask just arrived, then it will execute that, and that, and that, and that, and that. So basically, we're going to execute every microtask, including the new ones that have just arrived, even if they arrive while we are in this little loop. Now, if the microtask is empty, then we ask, is it time to repaint? Assuming that regular browser on a regular computer, there are 60 frames per second, which means that the repaint will happen every 16 milliseconds. Other browsers in other type of hardware may have a slower frame rates or maybe even faster frame rates. But typically, there's 60 frames per second, which means that the repaint will happen once every 16 milliseconds. Just about. All right, can you show us some code? Now, this next section, I built a website. There's the URL for that, eteventloop.herokuapp.com. Please feel free to visit this website because this is also going to help you understand the event loop a little bit better. So this tool, this website has multiple things. One of the things that it does have, it's a simulator. Now the simulator will help us understand how the event loop actually works. So the very first example is very, very simple. I don't have any promises or timers or nothing. The first example is just to show you how the UI with all these boxes actually works. Okay, so let's suppose that we copy this code and we open the inspector window and we paste it there and we hit enter. At that time, we are executing the code. And that's basically the way that I want to execute this. So when I click on this start button here, then pasting that into the developer inspector tool, then it's going to create a task and queue it for the anonymous blocks. It will then, because the stack is empty, and only if the stack is empty, then it will execute the first line, which is this console.log. So in the stack, we push the anonymous frame, and we print out start. Then we move to the next function. When it's called, we're going to push into the stack the second line, which is echo and hello moon. Then we print that in the console. Then we finish that. And when we return, we pop from the stack, we pop the echo function. We print finish. We pop the anonymous from the stack. The stack is empty. Okay, so I've shown you a couple of screens here, a couple of boxes here. We haven't talked about the web API. We haven't talked about the different queues, microtask queue, all that stuff. A little bit maybe. But let's take a second example. In this case, I'm going to define multiple timers. So the way that this code is going to run, it's once I run it, it's going to enqueue a task for the anonymous frame. Because the stack is empty, then it will execute that. And the first thing that it does is prints out a console.log start message. It will then call the function timers with a parameter of 3, which has a for loop, where we're going to print out loop and then the variable I. So we print loop 0. Then we have a set timeout for 1000 milliseconds. Notice that the code, this line here, is not going to be executed yet. But instead of that, this whole block here, what it's doing, it's telling the web API to please enqueue or create a timer for 1000 milliseconds, where when the timer is done, it is going to run lines 6 through 8, and with a parameter called j, which is this parameter here, having the value of the iteration loop variable. It will then continue, go back to the loop, and we loop through this doing loop 0, loop 1, and loop 2. We schedule them, but we don't run them yet because we haven't, the time has not elapsed just yet. Then we print out loops ended. Then we continue. We pop timers out of the stack. We print finish, and we pop anonymous from the stack. 1000 milliseconds later, all the timers will expire at once, which when they do expire, the web API will move them into the queue, into a task queue. We're going to take the first task and only the first task, and we're going to execute that, printing out the timer 0, and then we pop out from the stack. We do J1 and J2. Now let's take a look at an example for working with promises. A little bit more complex code. The way that this works, again, we're going to enqueue the task for the anonymous frame, and we're going to start with the log function, which we push into the stack. We execute it. Once it returns, we pop it out of the stack. Then we're going to call a function called timer. When timer gets invoked, it is going to have a timer for 0 milliseconds, which, having a 0 milliseconds, expires immediately, and it moves, the web API moves that into the task queue. But we're not going to run it because the stack is not empty yet. What we're going to do instead of that is we're going to print a log of a timer. We pop my timer from the stack. We go with the next line, which is a call to a function, which is my promise, which creates a new promise we're going to execute the constructor for that, which creates a variable of quality with some random number right there. It will then have a promise that resolve, which is a function which immediately resolves the promise. What is going to happen is that we are going to create a promise. We're just going to keep waiting somewhere in there. Once we are able to continue running, then we'll execute lines 14 to 21. Because we did a promise which immediately resolves, the web API takes that out of here and moves it into the microtask queue. But it's not run yet. We'll then print a log, and after promise log, we exit that, we return. Now, when we return here, my promise, the next thing that it does is handles a promise. Now, that promise, it is going to either successfully fulfill or failure, handle the catch. So we're going to put a promise on the web API saying, do execute lines 20 and 29 whenever you're ready to do so. Then we print log finish, which goes here. We print out, we pop that out of the stack. Okay, good. Now, we scheduled the timer first. This line 5.7 arrived earlier than microtask, but microtasks takes precedence. So we're gonna run this one first, now that the stack is empty. So we execute that. We print out a checking quality message. If the quality is greater than 0.1, which is not, then we're going to reject our promise. At this moment, because we are rejecting, it knows that it will have to execute line 29. But it's not executing it just yet because the stack is not empty. Then we will continue. Next, we're going to finish that first promise. And right now we are in this little loop here. We finished the first task. We go back and we ask, is the microtask queue empty? And it is not. So we go again and again until it is empty. So that when we have this microtask, and we'll execute that first, printing line 29, which prints out the big red X because it rejected, and a value right here, and we finish that. At that moment, the microtask is empty, so now we continue here. We may repaint the screen. It's about time to do so. If it is elapsed over 16 milliseconds, then we repaint it. Otherwise, we go through here, and we go back and we check to see if there's any tasks. And there is one task, which is line 5 through 7. Which we actually move that into the execution framework on the stack. We execute this line, which is a callback function which was invoked. We're just calling that function here. So we call the function, we print out a timer. We return, we clear the stack, and we are done. So now let's take a look at a couple examples that I want to show you. Look at this image of this globe spinning. What I want to do is when I click a button, I want it to go on and off 10 times for, well, 5 on and 5 off, 5 times for blinking. All right. So for doing that, what I'm going to do is I'm going to run this code. Now, I have another window here opened for the blinking of the globe on version 1, which is going to print something on the log. So when I click on version 1 button, it didn't blink as I wanted it to blink. So you would say, oh, it didn't do anything. Actually, it did do stuff. Take a look at everything that happened on the log. It looped 10 times, and it went off, on, 10 times. But They all happen in the same millisecond, these counters. And then half a millisecond later, all the timers time out at the same, almost at the same time. So it was so fast that we didn't have time to see the actual blinking of the globe. How did I wrote this code? So this is version 1. We're gonna do a loop for 10 times. If I'm still looping, then increment the counter and create a timer for half a second and flip the image. But we know that the image didn't flip, and we know that all the counters run at the same time because I schedule the timers at the same time. So all of them will expire 500 seconds from now. It's not what I wanted of doing expire and half a second later expire and half a second later expire and half a second later expire, half a second later expire, etc., etc. A way to build that code using the set timeout is that I'm going to create a function and I'm going to call that function here. When the function gets called, I'm going to flip the image and create a timer for half a second. I do not run this code. I just put it in the web API corner. Half a second later, it will be moved to the stack, and then it will be executed. Okay. So I schedule this 500 seconds, 500 milliseconds later. It's going to call the loop function, which is going to flip the image and call the loop function and loop. And this is going to be my loop for 10 times, or while I'm still looping. And in this case, the globe actually spins the way that I want it to spin. And notice that every half a second, I'm switching from off to on, off, on, off, on, off, on. And it spins, blinks 10 times. The second exercise that I want to do, it's on this loop. I basically want to have a button that when I click it, I get a spinner for 5 seconds. So there's a lot of stuff that I have to do in this particular task. 5 seconds later, it should go off. Now notice that I created a little button here, like using the salads button. When I click on it, and while the finger is down on the mouse, the button becomes red. Once I let it go, it becomes blue, and it performs the action. And do it again, and it becomes red, etc. And that red is going to be an important fact because what I want to show you is that the UI freezes. So let's run this code, but let's do it with the console open. So let me clear this, go back to loops, go back to a while loop. And what I'm doing here is I'm going to start my spinner. I'm going to do a loop for 5 seconds. 5 seconds is over. Then I'm going to turn the spinner off. When I make it run, notice the button is red. Notice the cursor is in the hand. It doesn't become an arrow until actually the 5 seconds are done. So what this loop actually did was it was stuck inside of this blue box on that loop here. So it never got out, never got time to repaint, never did anything. It was all stuck right here. So that's because I wasn't doing asynchronous programming. So let's build that with a promise and see if there's any difference there. Also notice, before I move on, I was doing about 2.1 million to 2 million iterations per second, right? Because I was basically looping like crazy right inside this blue box. All right, so let's do now a promise. Promise what it's going to do is going to create a function. What that function is going to do, if it is still looping 5 seconds, then I'm going to log it, and I'm going to create a promise that resolves to do asynchronous. A promise that resolves immediately, and then when it resolves, it's going to do a loop, and it's called this function, and that's going to be my loop for 5 seconds. If the time is done, I already looped for 5 seconds, then it is going to go in here and stop the spinner. Okay. So let's take a look at how that actually works. Notice the button is red. Notice that the cursor is a hand, and it goes to an arrow once the 5 seconds done. So the UI froze. Also notice that it was around 100,000 times per each iteration, right? Roughly 100,000 times. what it was happening here, you were stuck on this loop. You didn't have time to repaint because you didn't get out of this loop because I was doing that promise. So promise, yes, asynchronously, yes, but you may be stuck on a loop. What I'm gonna do is do the third example here using a timer. So the code between the promise and the code between a promise and loop is going to be very, very similar. The only thing is I'm changing this to a task rather than being a micro task. So then I'm gonna do this loop, and notice that when I click here, I do get the spinner. The icon is not red. Sorry, the button is not red, and the cursor went into an arrow as expected. But we only did 200 iterations per second because in this case we were doing one timer, then we were going around and doing the other timer, and then we were going around and doing the other time. So we did have time to go through the spinner. Now, through the repaint of the screen. Now, we were doing 230 times, but this is 60 frames per second, so it wasn't really redrawing every single frame. Some frames, the UI was just skipped, but that's fine because we were not really expecting anything to be displayed other than make sure that it didn't froze. So hopefully this demos has explained a little bit of how the event loop works in JavaScript. There is some resources. I did find some really nice videos from other people talking about the event loop, a little bit more deep than what I just went through. There is a specifications which goes into a very, very explicit detail, especially in something that I didn't really explain a lot, which is this of the repainting of the screen. Because you can have some tasks that you can, animation framework, which we can put inside that specific for the update of the screen. But I didn't really touch much in that because in Lightning Web Components, that's really handled by the platform, so we don't really have to worry about that. But if you want to learn how that is working, then you can go through the full specifications or watch some of these other videos. I will be putting the slides that I just went through with you guys as a resource here, and once we have the recorded session, we'll actually have it here as well. All right. So that basically covers what I wanted to talk about with the event loop for today's session. Was there any questions or any comments on the chat that we should address, Simon or Brad?
I'm just looking at the Q&A right now. It's empty right now, but it does take a while to type. So perhaps you've already mentioned some of the resources that's in your funky app that people can look at. Maybe you can say a few words about the JavaScript Developer 1 certification and then the cert prep materials.
Oh yeah, I did forget to mention that. Thanks, Simon. We do have, I do deliver a one-day class on JavaScript, on all the different concepts that are part of JavaScript, from JavaScript basics and data types and variables and coercing and all these things. We talk about objects and functions and inheritance, because in JavaScript, inheritance is a little bit different than traditional object-oriented programming. We talk about browsers and events, debugging and error handling, asynchronous programming, where this particular topic has a lot to explains a little bit more than we do in class. But it does. The class talks about all the different things you can do with callbacks and promises and the async and await, which is another way of handling promises. It does cover server-side JavaScript, including Node and some things, and then it does cover testing. This is one day. It's called CRT 600. You can find the link on their resources. There's also another course that takes 5 days to cover Lightning Web Components, with a lot of the exercises dealing with the concept that we just talked about, as promises and how you do chaining of promises and all that. All that. So yeah, thanks for the reminder, Simon.
Okay, thank you. Thanks, Andreas. Well, I don't see anything in the Q&A or really the room chats. Rad has kindly reminded us that there's a survey for this session, so
please do let us know your opinion. How do you like the presentation, please?
Okay, so I think you've stunned everybody to silence there.
Amazed,
Andres.
Hopefully, it was clear. Good. Best section. Thanks, Rutila.
Okay.
Thanks, guys.
All right. Thanks, everybody. Thank you, Andres. Thank you, Rad.
Thank you.
Thank you.